Hi guys, today we're going to learn how to define polar coordinates and differentiating in polar form. A little bit of a refresher from pre-calculus. Rectangular coordinates are in the form xy, while polar coordinates are in the form r theta. Okay, so whenever you are asked to graph the following polar coordinates, and let's start with A, you have 4, 2 pi over 3. What you're going to do is you're going to look for your angle. Remember that your location is always going to be at the origin or at the pole, and you're going to start, this is your angle 0. Okay, so 2 pi over 3, you're going to open up to this, 2 pi over 3. So look at your 2 pi over 3 here, and then what you're going to do, you're always going to be located here. You're going to walk 4 units towards your angle. 1, 2, 3, 4, and this is going to be your point A. Similarly, what you're going to do for B, you're going to look at, you start here, right, 7 pi over 6, so you do the full opening, you are here, right, you locate the angle, but you are going to walk 3 units towards the angle, so 1, 2, 3, and you find your point B. Now you're going to tell me, yeah, those are pretty easy, but how about when you have a negative 2? Well, what you're going to do is you find the 5 pi over 4, which you know that the 5 pi over 4 is here, okay? So technically speaking, you do the same, boom, and up to here, right? So you are here, located here, looking at your angle, and you're like, am I going to walk towards the angle? No, you're going to walk 2 units against the angle. Why against? Because it's negative. And guess what? That is going to be your C. You're going to tell me then, that's the same as saying 2 pi over 4, yes. Okay, it's the same, okay? So that should give you some pre-calculus vibes. Anyway, so D, what are you going to do for D? D is negative pi over 6. So you know that positive pi over 6, when we move to the angles, is here counterclockwise. So negative is going to be clockwise. So you know that this, okay, 11 pi over 6 is the same as negative pi over 6. Okay, so you have here your angle, so you're going to walk 2 units towards your angle, and this is going to be your beautiful point D. Okay, so hopefully this gives you a refresher from pre-calculus and plotting polar coordinates. Anyway, so talking about refreshers, okay, let's give you a good refresher here, maybe from middle school and pre-calculus and geometry. Okay, so all the combo. Okay, so you have your Cartesian plane here, x, y, and let's say, so this can give you like some geometry vibes. We're going to create a right triangle, that it was basically your best friend in geometry. What you have about this triangle that you have here, this point is going to be the point xy. What we know is that the horizontal component is going to be x and the vertical component is y. And you know that the hypotenuse is going to be r. Okay, so that's what you learn in middle school. Then in geometry, what you learn is your SOHCAHTOA, right? So you know that cosine, remember, okay, if you are here, you know that this is going to be your angle. Okay, so what's going to be cosine of your angle? It's going to be adjacent over hypotenuse. Adjacent is x, hypotenuse in this case is r. Sine is going to be what? Opposite over hypotenuse, and tangent is going to be opposite over adjacent. Okay, so that's what you learn in geometry and middle school. Also in middle school and geometry, you learn about the Pythagorean theorem. You know that x squared plus y squared is equal to the hypotenuse squared, which in this case is r squared. Therefore, in pre-calculus, what you learn is that x is going to be equal to what? You put the r there, so r cos theta, and y is equal to r sin theta. Okay? In the same way that you know that theta is going to be equal to tangent inverse of y over x, always respecting the restrictions of the tangent inverse, which are quadrant 1 and 4. And also from here, you know that r is going to be positive square root of x squared plus y squared. Okay, hopefully this gives you all information vibes. Okay, and we're going to use all of this now that we're working in polar, so you might not see it immediately, but little by little we're going to use them all. Okay, so now I'm going to refresh your memory about how to convert polar coordinates into rectangular coordinates. So they tell you 2, 5 pi over 6 to rectangular. What you see here is that this is r and this is theta. Do you agree with that? Okay, so if I want rectangular coordinates, aka I want x, y, what are we going to do? You know that x is going to be equal to r cos theta. So in this way, you have that x is going to be equal to 2 cosine of 5 pi over 6. Okay, and then you know that this is going to be equal to 2 times what's going to be cosine of 5 pi over 6. You know that 5 pi over 6 is going to be negative root 3 over 2, giving you that this is going to be equal to negative root 3. In the same way that you know that y is going to be equal to r sine theta. Okay, you know that in this situation your y is going to be 2 sine of 5 pi over 6. What we know here is that this is going to be equal to 2, and you know that sine of 5 pi over 6 is going to be 1/2, therefore you have that this is going to be 1. Okay? Therefore, what do you have here? You know that your point xy is going to be equal to, what's that? Negative root 3 comma 1, and that's pretty much what we have. Okay? Now, what happens if we have the opposite situation? They give you rectangular and they want polar. So they give you xy here, but they want theta. That's very possible, right? So what would be my preference here? It would be to find r first. So you know that r, this formula, you're going to use that one. So it's going to be 3 squared plus negative 3 squared. Okay, everything inside the square root. So this is going to be root 18, which you know that you can simplify as 3 root 2. So you have your r. Now your theta, you know that theta is going to be equal to tangent inverse of y over x, which is negative 3 over 3, meaning that you are looking for the tangent inverse of negative 1. The great thing about this one is, think about something. It's in quadrant 4 because tangent should be negative there, okay? You know that you are respecting the restrictions of the tangent inverse, which is quadrant 1 if it's positive, quadrant 4 if it's negative. In this case, it's negative. That's why I immediately told you, hey, this is in quadrant 4. So what is that angle? That angle is going to be 7 pi over 4, okay? Therefore, what do you have here? You have that your polar coordinates r comma theta is going to be equal to 3 root 2 comma 7 pi over 4, okay? So that's what we have. Cool? For this example, what we have, we want to convert the following equations to polar form. So they give you rectangular equations and they want polar form. So what's y? You know that y is going to be equal to r sine theta, okay, and that's going to be equal to 4. So solve for r, okay, solve for r, and what do you have? You have that r is going to be equal to 4 divided by sine of theta, or this is going to be equal to 4 cosecant theta. Either way, they are correct because you already isolate your r and you have something in terms of theta, so you are happy. Either way, it would be correct. Which one is better? Honestly, both are correct. Then over here, you have that x squared plus y squared is equal to 25. So you have that this is r squared and this is equal to 25. Then you have that r is going to be equal to 5. So I'm going to leave it like that, okay, respecting the idea. And here, let me show you from here, okay, yes or no? So that's what we have. Cool? Okay, so the next one that we have over here, you need to convert the following equations to rectangular form, okay? So they are giving you something in polar form and they want you to do rectangular form. So this one, you see r sine theta, and this gives you y bar, so y equals 3, which is a pretty user-friendly equation, okay? So you know that it's an horizontal line at 3, so I'll just do that, okay? So you have the situation over here. Okay, so you have that that's going to be your equation, y equals 3, and that's pretty much it. Okay, now this one. You're going to tell me, well, this one, we have r is equal to 2 cosine theta. So the problem here is that you don't have r cosine theta, so you don't see the x. And you don't have r squared, and we're not going to work with cosine inverse, okay? So that one, not a good idea, okay? So what we're going to do here, we're going to multiply both sides times r. So you have that r squared is going to be equal to 2r cosine theta. So this is beautiful because I know that r squared is going to be x squared plus y squared, and on the other side I know that 2 times x is going to be the same as 2r cosine theta. So here I love it. Why? Because I have all x's and y's, and then I'm going to move the 2x to the other side, having x squared minus 2x Okay, and I'm going to put a parenthesis so you can see what is giving you vibes of completing the square, right? So you complete the square here and here, so you divide by 2, so you have negative 1 squared is going to be plus 1 here and plus 1 here. So this gives you, when you complete the square, x minus 1 squared plus y squared is equal to 1. So you can see that this is a circle centered at the point 1, 0, which is here, with radius 1. So I go ahead and draw my situation here, and you have that beautiful circle here. Okay, so that's what we have. It's very beautiful. I would leave it like that because that's, you know, that's the general equation of a circle. Of course, you can do the y equals whatever, but since it's a circle, I would leave it like that. When it's a conic, I like to leave my equation as a conic. Okay, so it's clear for the reader that you have a conic. Okay, so the next one that we have over here, you have a theta equals 2 pi over 3. So you're going to tell me, so what are we going to do? Well, what you can do is, you know that theta, okay, is going to be equal to what's theta? Tangent inverse of y over x, and that's going to be equal to 2 pi over 3. I will go with that, but here the business is, how can we get rid of that tangent inverse? You tangent both sides. Okay, if we apply the tangent function to both sides, you have that it's going to be, obviously respecting the restrictions, you have that it's going to be y over x is equal to tangent of 2 pi over 3. Do you see it? Now, ask yourself, what in the world is tangent of 2 pi over 3? You know that tangent of 2 pi over 3 is going to be equal to negative root 3. So what you have here is the beautiful equation y equals negative root 3x, which is a linear equation, and you can see that at the end of the day, negative root 3 is a constant, so you have a linear equation with a negative slope. So here, guesstimating, okay, so it's a little bit steeper than 1. So that's my guesstimation, okay, so I know that it's not perfect, this line, but it's something like this, okay, so you have that your equation should look as something like this, okay. Happy? So you can see that each one of those has different tricks. Now, let's move back to calculus, okay? Because all of that we just saw, I'm pretty sure it looks familiar from pre-calculus, okay? But why we learn this? So we can arrive to the calculus part. Okay, to find the slope of a tangent line, okay, so this is already looking like calculus. To a polar graph, let's say that it's r equals f of theta, we can use the facts that x is equal to r cosine theta and y equals r sine of theta together with the product rule to find the following. So on previous lessons, we learned that the first derivative of a parametric equation is equal to dy dx equals dy dt divided by dx dt. Instead of having the parameter t that we had back in the day, we have the parameter theta. So that's why we have dy d theta divided by dx d theta. Now, we need to take the derivative of the y and the x, as you can see here. Okay? So what do you see here? The first thing that I see on the y is that you have a multiplication of the variable r and sine theta. So what are you going to apply here? A product rule. Okay, so what are you going to do here? The first one times the derivative of the second one, which, what's the derivative of sine of theta? Cosine theta, d theta, so it's a 1. Plus, and then you have that it's going to be the sine of theta times the derivative of r. The derivative of r is 1 dr d theta. Okay, so be very careful that you need to take the derivative of that implicitly, okay, because we're taking the derivative with respect to theta of that expression. Now, similarly, we're going to take the derivative of the x, okay, component. So you have that it's going to be r times cosine theta, so you have r times the derivative of cosine theta, which is negative sine of theta, plus the cosine theta times the derivative of r. The derivative of r is 1 dr d theta. Now, if you go to textbooks or formula sheets, what you're going to see is that they condense it and they reorganize it. How? They are going to reorganize it like this. R cosine theta, and then they put the dr d theta or r prime, whatever is the notation that the textbook or the formula sheet is using, depending on the situation. And then you have that it's going to be negative r sine theta plus dr d theta, okay, cosine theta. I will cover that. So this is going to be the formula that most likely you are going to see in formula sheets and things like that, okay? Please note that dr d theta is the same as r prime, okay? Remember that y prime is the same as dy dx, okay? So it's the same notation that we have over here, okay? If you like the dr, d theta, keep it like that, enjoy it. And this is the formula that we have for the slope of a tangent line for a polar curve, okay? So anyway, let's apply it so you can see that it's pretty simple. Okay, so find dy dx. Please note that they are telling you dy dx. Some students, they freak out because they don't see thetas or they don't see x's. Don't worry, this means the derivative of a polar equation. Okay, so and the slope of the graph of the polar curve at the given value of theta. Okay, so what are you going to do first? They give you that r is equal to 3 plus 2 sine of theta, and theta is equal to pi over 6. So the first thing that I would do, I would find my dr d theta. What's dr d theta? It's the derivative of this little thingy here, okay? So you know that this is 0, then you have that this is 2 cosine theta d theta d theta. Okay, so this is the derivative, okay? So what are we going to do here? To apply the formula dy dx, and they want it evaluated at theta equals pi over 6. So what you're going to do is you are going to follow this, okay, this formula. Okay, what is r? R, they gave you from the hypothesis of the problem that it was 3 plus 2 sine theta. Okay, then you have the cosine theta. Okay, close it, plus then you have r d theta, which is going to be what? 2 cos theta. Okay, and then you have the sine of theta that you have from the formula, okay, here. Okay, so we are in the numerator. Now, what's the business with the denominator? The denominator, you start with a negative, then the r, 3 plus 2 sine theta, which is your r. Then you have the sine theta here. Then you have a plus, then you have a 2 cosine theta, and then you have a cosine theta there. But that's not it. We need to indicate the reader that we're going to evaluate when theta is equal to pi over 6. So you have this equation. Everybody with me? So what are you going to do here? You are going to evaluate. So what do you have here? You have 3 plus 2, and you know that sine of, what was it? It was pi over 6 is going to be what? 1/2, okay? Cosine of pi over 6 is root 3 over 2, okay? Plus 2 cosine root 3 over 2, okay? Because that's cosine of pi over 6, and 1/2 because that's the sine of pi over 6. Okay, then you are going to evaluate the denominator to 1/2 here, then you have another 1/2 here because it's sine of pi over 6, then you have a plus 2, then you have a cosine of pi over 6, which is root 3 over 2, and then you have another cosine, which you can put it square instead of that, whatever is your preference, that would work. Here I don't need to put that I'm evaluating at theta equals pi over 6 because I already evaluate, so I'm telling the reader, hey, I evaluate this because I do know my unit circle by heart. Okay, so then you have that this is going to be 4 times root 3 over 2, so you have 2 root 3. Okay, and this one is going to be plus root 3 over 2. Okay, then the denominator over here, and I skip the negative, so, but don't worry, I remember it, so I put it here. So you have that it's negative 2 plus, and then you have that that one is going to be at 3 over 2. Okay, so watch out with those numbers there. Okay, so that's going to be 5 root 3 and then negative 1. Okay, so then it's going to be negative 5 times root 3, and that's pretty much what you have. If you want to conclude or being extra, you can go ahead and put those dy dx evaluated at pi over 6. Okay, is going to be equal to negative 5 root 3. That would be okay, but either way, if you are indicating this situation, you would be fine either way. Okay, so I hope that you find this video helpful. Bye.